Hello, Cosmic Explorers, and welcome back to Mystifacts 2.0, your go-to channel for unraveling the mysteries of the universe. Today, we're venturing beyond our solar system to explore one of the most exciting questions in astronomy. Are there exoplanets out there capable of supporting human life, just like Earth? With thousands of exoplanets discovered, a select few stand out as potential havens in the vastness of space. These distant worlds, orbiting stars light years away, might hold the key to humanity's future among the stars. From rocky super-Earths to ocean-covered planets, we've curated a list of the top 10 exoplanets with the best chances of habitability. So buckle up for an interstellar journey, hit that subscribe button, and ring the notification bell to never miss a cosmic adventure. Let's dive into the stars. Number 10, Kepler-62f, the ocean world in Lyra. Kicking off our list is Kepler-62f, a super-Earth exoplanet orbiting within the habitable zone of its star, Kepler-62, a K-type main sequence star located 990 light-years away in the constellation Lyra. Discovered by NASA's Kepler Space Telescope in 2013, Kepler-62f has an orbital period of 267.3 days and a radius about 1.4 times that of Earth. Its mass, estimated at 2.8 Earth masses, suggests it could be a terrestrial planet with a rocky surface, possibly covered by vast oceans or ice. What makes Kepler-62f intriguing is its position in the habitable zone, where liquid water could exist, a key ingredient for life as we know it. Its age, potentially up to 7 billion years, and its moderate stellar irradiance make it a strong candidate for habitability. Studies suggest it could have a silicate iron composition with significant water content, perhaps resembling a global ocean with rocky continents. Some models even propose it could host moons, which might stabilize its climate through tidal effects, much like Earth's moon. However, challenges remain. Being the outermost of 5 planets in its system, Kepler-62f may require a thick atmosphere rich in carbon dioxide to trap heat, as it receives less stellar energy than Earth. Without sufficient greenhouse gases, it could be a frozen world, its oceans locked in ice. Scientists are still investigating its atmospheric composition and density, which are critical to determining if it could support human life. As of 2025, advanced telescopes like the James Webb Space Telescope, JWST, are studying Kepler-62f for biosignatures, such as water vapor or oxygen, that could confirm its potential. This distant world offers a tantalizing glimpse of a planet that might mirror Earth's watery beauty. Number 9. Kepler-186f, Earth's distant twin. Next up is Kepler-186f, a historic discovery as the first Earth-sized exoplanet found in the habitable zone of its star, Kepler-186, a red dwarf located 582 light-years away in Cygnus. Announced in 2014, Kepler-186f has a radius 1.1 times that of Earth and orbits its star every 129.9 days. Its host star, a cool M-type dwarf, is smaller and dimmer than the Sun, meaning the habitable zone is closer to the star, but Kepler-186f sits comfortably within it. Kepler-186f's Earth-like size suggests it could be rocky, but its habitability depends heavily on its atmosphere, which remains unknown. It receives about 32% of Earth's solar flux, requiring a dense atmosphere with strong greenhouse effects to maintain liquid water. Unlike Earth, its low axial tilt, if any, means it likely lacks pronounced seasons, which could affect climate patterns. The other 4 planets in the Kepler-186 system orbit too close to the star, making them too hot for liquid water, but Kepler-186f's position gives it a fighting chance. Red dwarfs like Kepler-186 pose challenges. Frequent stellar flares could strip away atmospheres, and tidal locking might create extreme temperature differences between the planet's day and night sides. However, a thick atmosphere could redistribute heat, making it habitable. In 2025, astronomers are using JWST to probe Kepler-186f's atmosphere for signs of water or methane. If it has a stable climate and liquid water, it could be a prime candidate for human colonization, or even alien life. Kepler-186f stands as a milestone in our search for Earth's cosmic twin. Number 8. Kepler-442b, the most Earth-like super-Earth. Kepler-442b, confirmed by NASA on January 6, 2015, is a near-Earth-sized super-Earth orbiting in the habitable zone of its K-type star, Kepler-442, about 1,206 light-years away in Lyra. With a radius 1.34 times Earth's and an estimated mass of 2.3 Earth masses, it's likely rocky, with surface gravity about 30% stronger than Earth's. Its orbital period is 112 days, and it receives 70% of Earth's solar flux, placing it squarely in the habitable zone where liquid water could exist. Described as one of the most Earth-like exoplanets in terms of size and temperature, Kepler-442b is a top candidate for habitability. Its star, cooler than the Sun, provides stable radiation, and the planet is not tidally locked, allowing for more uniform heat distribution. Models suggest it could have a rocky surface with oceans or continents, potentially supporting Earth-like ecosystems. A 2018 study ranked it as the most habitable, non-tidally locked exoplanet known, based on its Earth Similarity Index, ESI, of 0.84. Earth equals 1.0. Challenges included stronger gravity, which could affect human physiology, and the lack of atmospheric data. If it has a thick thick atmosphere with greenhouse gases like CO2, it could maintain a temperate climate. Recent observations in 2025 using ground-based telescopes like the Extremely Large Telescope, ELT, aim to detect atmospheric biomarkers. Kepler 442b's balance of size, temperature, and stellar environment makes it a beacon of hope for finding habitable worlds. Number 7. Kepler 452b, Earth's older cousin. Often dubbed Earth 2.0, Kepler 452b is a super-Earth orbiting a Sun-like G-type star, Kepler 452, about 1,402 light-years away in Cygnus. Discovered in 2015, it has a radius 1.6 times Earth's and an estimated mass 5 times greater, orbiting every 385 days in the habitable zone. Its star is 1.5 billion years older than the Sun, suggesting Kepler 452b could offer clues about Earth's future as our star ages. With twice Earth's surface gravity, Kepler 452b might be a rocky super-Earth with active volcanism due to its higher mass and density. It receives 10% more stellar flux than Earth, potentially supporting liquid water if it has a suitable atmosphere. However, its mass raises the possibility it's a mini-Neptune with a thick gaseous envelope, which would make it less habitable. If rocky, its clouds might be dense and misty, obscuring much of the surface. The planet's habitability is uncertain due to unknown atmospheric conditions and potential greenhouse effects. Its older star may have increased radiation over time, risking atmospheric erosion. In 2025, NASA's continued analysis via JWST seeks to clarify its composition. Kepler 452b's Earth-like orbit and Sun-like star make it a fascinating candidate, but it may be more of a volcanic super-Earth than a true Earth twin. Number 6. Kepler 440b, a super-Earth in the Goldilocks zone. Kepler 440b, another super-Earth, orbits the K-type star Kepler 440, 850 light-years away in Lyra. Confirmed on January 6, 2015, it has a radius 1.86 times Earth's and orbits every 101 days in the habitable zone, where liquid water could exist. Discovered via the transit method, which measures a star's dimming as a planet passes in front, Kepler 440b is likely rocky, with an estimated mass of 2 to 4 Earth masses. Its star, cooler than the Sun, provides stable conditions, but Kepler 440b's larger size suggests stronger gravity, potentially affecting human habitation. It receives slightly less stellar flux than Earth, requiring a robust atmosphere to maintain liquid water. Models indicate it could have a mix of rocky terrain and oceans, but data on its atmosphere is sparse. In 2025, astronomers are using the ELT to study its potential for water vapor or other habitability markers. Kepler 440b's position in the habitable zone and its rocky nature make it a strong contender, but its distance and lack of detailed atmospheric data keep its habitability speculative. It represents the promise of super-Earths as potential homes for humanity. Number 5. Kepler 438b, the radiated Earth twin. Kepler 438b is an Earth-sized exoplanet orbiting the red dwarf Kepler 438, about 472 light-years away in Lyra. Confirmed in 2015, it has a radius 1.12 times Earth's and orbits every 35.2 days at the inner edge of the habitable zone, receiving 1.4 times Earth's solar flux. Its ESI of 0.88 makes it one of the most Earth-like planets known, suggesting a rocky surface. However, its red dwarf star is prone to violent stellar flares every 100 days, releasing X-rays and UV radiation that could strip its atmosphere or sterilize life. These flares, far stronger than the Sun's, pose a major hurdle to habitability. If Kepler 438b has a strong magnetic field or thick atmosphere, it might retain liquid water, but it could resemble a hotter, barren Venus. Recent 2025 studies suggest its atmosphere may have been eroded, reducing its habitability score. Despite these challenges, its Earth-like size and position make it a key target for JWST observations, seeking signs of water or biosignatures. Kepler 438b reminds us that habitability involves more than just distance from a star. Stellar activity is a critical factor. Number 4. TOI 700d, TESS's first habitable zone Earth. Discovered by NASA's Transiting Exoplanet Survey satellite TESS in 2020, TOI 700d is an Earth-sized exoplanet orbiting the M-type red dwarf TOI 700, 101.4 light-years away in Dorado. With a radius 1.14 times Earth's and an orbital period of 37.4 days, it receives 86% of Earth's solar flux, placing it in the habitable zone. Its star, 40% the Sun's mass and radius, is relatively stable for a red dwarf, reducing flare risks. TOI 700d is likely rocky, with models suggesting a potential for oceans or a thin atmosphere capable of supporting liquid water. Its solar ram pressure and magnetic field are estimated to be Earth-like, aiding atmospheric retention. Unlike tidally locked planets, it may have a day-night cycle, if not fully locked, enhancing habitability. In 2025, TESS follow-ups and JWST observations are analyzing its atmosphere for water vapor, or CO2. As TESS's first habitable zone Earth-sized planet, TOI 700d is a milestone. Its proximity and stable star make it a prime candidate for future study, offering hope for a habitable world within reach of our telescopes. Number 3. Proxima Centauri b, our closest neighbor. Proxima Centauri b, orbiting the red dwarf Proxima Centauri in the closest star system to the Sun, 4.2 light-years away in Centaurus, is the nearest potentially habitable exoplanet. Discovered in 2016, it has a minimum mass of 1.17 Earth masses and orbits every 11.2 days in the habitable zone. Its ESI of 0.87 suggests Earth-like qualities, but its red dwarf star complicates things. Proxima Centauri's frequent flares and stellar winds, 2,000 times stronger than the Sun's, could strip the planet's atmosphere, leaving only the subsurface as potentially habitable. Tidal locking is likely, creating a hot day side and frozen night side, though a thick atmosphere could redistribute heat. A 2023 study suggested possible water oceans if the planet retains an atmosphere, and 2025 JWST observations are targeting biosignatures like methane. Despite its proximity, Proxima Centauri b's habitability is uncertain due to radiation and tidal locking. Projects like Breakthrough Starshot aim to send probes, making it a tantalizing target for humanity's first interstellar mission. Number 2. Gliese 667cc, the warm super-Earth. Gliese 667cc orbits the red dwarf Gliese 667c, part of a triple-star system 23.6 light-years away in Scorpius. Discovered in 2011, it has a minimum mass of 3.8 Earth masses and orbits every 28.1 days in the habitable zone, absorbing slightly more radiation than Earth, making it warmer. Its star's longevity, up to 150 billion years, suggests a stable environment for life. However, a 2013 study revealed tidal heating 300 times Earth's due to its eccentric orbit, potentially causing intense volcanism that could hinder habitability. Tidal locking is possible, but a thick atmosphere might mitigate temperature extremes. Recent 2025 models suggest it could have liquid water if its atmosphere is dense enough. The ELT is studying its composition, and its ESI of 0.85 keeps it high on the habitability list. Gliese 667cc's proximity and potential for water make it a compelling candidate, but its geological activity remains a question mark for human settlement. Number 1. Wolf 1061c, the tidally locked haven. Topping our list is Wolf 1061c, a super-Earth orbiting the red dwarf Wolf 1061, just 13.8 light-years away in Ophiuchus, making it the 5th closest potentially habitable exoplanet. Discovered in 2015, it has a mass 4.3 times Earth's and orbits every 17.9 days in the habitable zone. Its ESI of 0.86 suggests Earth-like potential, but tidal locking is likely, with one side facing the star and the other in perpetual darkness. The terminator zone between the day and night sides could be temperate, supporting liquid water if the atmosphere is thick enough to transfer heat. Models suggest oceans or rocky terrain, and its stable M-type star reduces flare risks compared to other red dwarfs. In 2025, JWST and ELT observations are probing for water vapor and oxygen, key indicators of habitability. Wolf 1061c's proximity and balanced conditions make it a top contender for future exploration, possibly hosting life in its twilight zone. It's a cosmic beacon of hope for humanity's interstellar dreams. And there you have it, the top 10 exoplanets that could potentially support human life, from ocean worlds to Earth-like twins. These distant planets spark our imagination and push the boundaries of what we believe is possible in the universe. Which one excites you the most? Let us know in the comments below. If you enjoyed this cosmic journey, give us a thumbs up, share this video with your fellow space enthusiasts, and subscribe to Mystifacts 2.0 with notifications on for more stellar adventures. Until next time, keep looking to the stars.